So I guess that now you're seeing the proper screen, right?
Yes, the portal.
Okay, so here is a basic portal that you are going to use. You saw a little bit earlier how it looks through Redshift's screen. It is a standard bootstrapping template. You log in via this address here. You have the left vertical menu, which will not be fully available to you because we are only experimenters. You are not testbed providers, so you can forget, for example, for this menu here. This is the very basic welcome page. If you click on the home menu, you will see also some links for the guides where it basically redirects you to Moodle. And also you can have a quick link here for the handbook that was presented before by Tiago. In the contact us page, there are the basic links for the support. Here you can have a quick access to the ticketing system that I mentioned earlier, which you can find either here or via this quick link here. And it does exactly what I mentioned before through the website. You can also find some statistics here with respect to reasoning or to the number of sensors that are registered to the system. And you can find a quick statistics table here for the number of testbeds and the assignment to the different domains. And the experiments, we have to update this with now your experiments through the OpenCall4. But these are basically the previous experiments and how they map to the testbeds that are available and integrated in the platform. Now, in the experimenter menu, we have the experiment register client. If you want to upload your own Fed spec, and the management console that was described before by Ratchit. In the tools, you don't have the certification because you are not testbed providers. You can have a quick link here to the monitoring tool that will be presented by Ronald a little bit later, and the reasoning module that I will present in a while. You can also see some sample experiments here to see what the FIESTA team has developed. And you will have here also a quick look at the help menu where you can find links to the support and the FIESTA IoT testbed or all the documentation for all the APIs developed by the FIESTA IoT team. So you can have here, for example, a link to the Moodle, to the deliverables, to the experiment execution engine, APIs, etc., etc., etc. Here you also have a quick link to the YouTube and Twitter and SlideShare channels. And okay, if you want to sign out, of course, you can do it easily by here. I don't think that I have to present something else to you. So, Luis, we can continue.
Okay, thank you, Elias. And now just we'll directly go over the different presenters for some of these tools that Elias has presented, and which let's say most of them are accessible through the portal as Elias has just presented. So first of the tools that we will present is this monitoring, which basically will show you more or less which is the health of the system. Let's say which data is continuously coming to the platform. This will be just mainly for informational purposes. So I will just hand over to Ronald. Whenever you're ready, you can just briefly present which are the motivation and the bits and pieces of the monitoring of testbeds.
Can you hear me now?
Yes, now we can hear you.
Okay. So I guess you can see my screen now. Smaller.
Now it's the portal with the monitoring there.
Okay, so you can see it. Okay, so here we are at the landing page. You see here a map where all these testbeds that are enabled now. These are only the 4 testbeds that are from the consortium. So we have the Smart Thunder testbed, the Smart ICS from the University of Surrey, the Caddy testbed, and the Sound City testbed in Paris. And here you have an overall overview about how much sensors are registered at all in the system, and how much of them have sent something in the last day. So, for example, if we want to have a look.
Sorry, Ronald, to interrupt you. Let's say your browser has gone to the development platform. I don't know if you just make. For one moment, there was the real platform, but then I don't know if you refresh or you just
I think
accidentally close it.
It should be seen again, yeah?
Yeah, it was.
So, okay, so from here on, we can go, for example, to the Smart ICS testbed. So when you click into one of these lines, then you will see a more detailed view. Make it a bit bigger. Here you have also a map, and then every sensor of the system is shown here. And for example, what you can see is the name, the internal of the testbed monitoring itself, the quantity kind, the unit, and also the value and the date and the location. And all the unit and quantity kinds are M3 Lite units, so it was removed. And as you can see here, for example, here you see last date and last value was none. So in the last few days since it was started, there was not an observation for this sensor. But if we are scrolling down, and there should be some that are fine. And for example, here we can see there was a value which was 29.27 degrees Celsius. It was on November the 17th. And for example, if we click on it, then you see a modal where you see all the observations. And here you can see in the last time there were some, which is stated here as 0, but it is none. I think it's special for this testbed when there is not a number, this will be sent, and it's shown in the graph as 0. But there should be also some sensors that have sent something in the last day. For example, this power sensor, and here we can see that this one was sending data for the whole time. And additionally to the graph, you can also see the sensor name that is used by the IoT registry, so that you can reuse it, and the quantity kind and the power. And so for this here, you can use this one to check what is the state, and also what were the latest observations of every sensor that you maybe take into account for an experiment. And this is the state as it is now. It will be added with some functionality later, but until it is now, it can be used for this. So thank you very much, and if there are no more questions, I will hand over to the next.
Okay, thank you, Ronald. I think that, let's say, that the main idea for this, as I mentioned before, and I think that Ronald has also explained, is this for informational purposes and for graphical informational purposes, because basically all the information, as it will be mentioned to you later and informed to you later, can be obtained through the, let's say, through other more programmatical APIs. But just for quick reference and for graphical reference, I think that it makes sense to have it here. Next tool is on the analytics that can be done over over the system, I will hand over now to Ali Reza from University of Surrey. And now, Ali Reza, whenever you are ready, please, you can go on.
Hi, yes. Today I will be presenting the FIESTA analytics tool. Can you all see my screen?
Yes, we can.
Okay, perfect. Just to note, there is a slight issue with regards to the accessing data from the development machine using the tool. So unfortunately, I'm not able to give a presentation with real data, but I will go over that in a second. But let me just go over some of the slides with regards to the tool. What we are trying to do is provide a tool which enables a variety of experimenters with either expert or limited knowledge access to a range of data analytics techniques. In particular, our tool focuses on using or has the following steps, namely the data pre-processing, which effectively conditions the data for further analysis. So in particular, data pre-processing will cover outlier removal, noise removal through digital filtering, and potentially other types of data pre-processing techniques and data conditioning techniques, such as first differencing, etc. From there, we have machine learning techniques, and that's broadly split into two categories, namely supervised learning and unsupervised learning techniques. And finally, we have other techniques which we can also incorporate, such as correlation analysis and spectral analysis, etc., etc. So, in particular, the digital filtering is what's known as a FIR filter, and the experimenter can specify the parameters for the FIR filter, and they can do a range of filtering techniques from low-pass filtering, bandpass, and high-pass filtering. The outlier removal is a very standard technique which is known as Windsorization, and effectively the user specifies one parameter in order to control how much, or the sensitivities to how much of the outliers they would want to remove. Now, the machine learning is broadly split, as I said previously, into two categories, namely supervised and unsupervised learning. So in supervised learning, we have basically an input-output relationship with respect to the data. So we specify an output and an input, and we want to train a model which relates the input and output. And we've selected two techniques for that. One is linear regression, where we assume the input-output has a linear relationship, and k-nearest neighbors, which is a fairly straightforward technique for representing the input-output relationship for when there's a non-linear relationship between the two. So if this linear relationship doesn't hold, then we can use something like k-nearest neighbors. And again, it's a very simple method to use for the experimenter, requiring only one parameter to be specified. Furthermore, with unsupervised learning, we want to find patterns which are not which exist in the data where there isn't necessarily an input-output relationship. So if we want to, for example, cluster the data, as an example, we would use clustering techniques, which we've included k-means clustering, or we want to find other types of information, such as the direction of height, or a more meaningful representation of the data, using something such as principal component analysis. We can take very large data sets, for example, and boil it down into a smaller or lower dimensional data sets so that we can find patterns of interest more easily. And finally, with regards to other techniques, we've included spectral analysis methods, which are the fast FFT and the periodogram, where we can look at how much energy there is at each frequency of the signal, and that gives us an indication, for example, of for example, this is particularly useful for digital filtering. For example, if we have a signal or a data sensor observations which we want to analyze, we look at the spectrogram or periodogram or the FFT, we can carry out digital filtering more effectively. And again, correlation helps us find dependencies between sensors. So if there's a strong relationship between two types of sensors, correlation can give us a useful measure for that. So here it would have been good if I show. The interaction with the tool is basically you specify a set of methods. So in this case, I'm showing outlier removal and k-means. And what happens is the tool will sequentially process these methods. So outlier will be followed by k-means. Furthermore, for each method, we'll have a set of parameters. And again, there's a user guide for this to explain what parameters are required for what method. And so in this case, we have outlier removal where we have to specify the threshold for how many outliers we would want to remove. And for k-means, we define what's known as the number of clusters. And here we're trying to output the number, or this here, this parameter specifies what kind of output you'd want to receive. After that, we have the Sparkle query. In this case, it was actually for power sensor data from the University of Surrey testbed. And furthermore, we provide the Sparkle endpoint. As you can see, if I run it, hopefully I might get data. Okay, no. So I'm unfortunately not able to obtain data from the dev machine. But in general, what will happen is the results will be followed by effectively the process data, and then you can in a CSV format. And a nice example would be shown here, for example, where we are processing two power sensors, and we're actually applying FFT here. So this first column corresponds to the frequencies. This second column corresponds to the output of the first sensor using FFT, and the third column, excuse me, corresponds to the output of the second sensor when applying the FFT. And so, yeah, there is a specific convention that needs to be followed, in particular sensing device, data value, and date time when carrying out the Sparkle query. This is important because the tool requires knowledge of the timestamp, and one way of doing that is by following a certain protocol for the query. And yep, this is a bit, I mean, I won't go over this. And yep, so this is an overview of our tool. I'm very sorry that I was not able to actually show process data at the outcome. But yep, this is an overview of the Unix testbed, or the FIESTA analytics tool.
Okay. Thank you, Liretsa. I think that key thing is that from this documentation that Elias showed you, that in the portal is available, the API for these FIESTA analytic tools documentation is there, and then you can, if your experiment requires it, or if your experiment can benefit from this analytics that the platform can provide, you just have to go there and learn how to actually execute it and get information from it. Okay, we will continue with the next tool, which is let's say another way of post-processing the raw data that you can access from the FIESTA platform. And in this case, instead of directly getting the raw data and having to do the post-processing in your own premises or experiment, to have a kind of added value data. One is the analytics, as Alireza has already presented. The next one is the reasoning engine that is able to also provide the platform. I don't know, Elias, if you or Hung who should I make presenter for?
Make me, I will do it.
Okay. Okay, so I now give you the presenter role, and then whenever you are ready, just please go on.
Yes. So, okay, wait. Okay, that should be more or less okay now. So, with respect to reasoning, what we have created is basically a component that is a rule-based engine, and you are able to create rules in the form of if then else. So you can use it basically to create simple rules, as you can see in this web page in the example. If the temperature of one sensor is greater than 25 degrees, then you can notify that it is hot in the room. Or if the speed of a car is less than 30 kilometers, then you can notify that there is some traffic. You can also create multiple rules at the same time. So if the temperature is less than 19 degrees and the humidity is greater than 60%, then you can notify, for example, that it is unhealthy conditions in the room. And as a basic overview, we have here this reasoner service engine, which is the main component. And you can use it in two different ways, either through a user interface that I will show you right now in the platform, or using the REST API that the platform, that the engine is providing. And the engine is composed of three components: the rule creation API, the rule registration, the rule execution. But let's go now to the portal and see it in real time. So I don't know what you are seeing right now. Wait one moment. Let me show you the correct platform, the correct version of the Firefox. Which one now will it be? So do you see now the portal?
Yes, we do.
Okay, perfect. So you saw the platform earlier, the portal earlier. If you go to the tools, you can find the reasoning tool here, which, as I mentioned, has three different components: to create a rule, to register a rule, and execute a rule. So at first, you want to create a rule, which is basically a template for a rule. And if you know about semantics in SparkQL, you can use this link here for creating your rule as a semantic expert, which basically has some fields for giving a name to the rule, a description so that you know what the rule does. And then what you do here is that you want to select the quantity kind that corresponds to the sensor for which data you want to apply the rule. And then it will show here the, well, let's try. For example, in air pollution, it will give you here the list of available sensors that are providing air pollution data in the FIESTA platform. And by selecting one of these sensors, then you can see here some information, for example, where it is located, what is the unit of measurements, and an example of the data that you get for this sensor. Then if you are experts in semantics, you can create your own rule here. But let's go to the non-semantic expert, which is much simpler, and let's try to create a new rule. If you want to also write a description here, and let's try and select a power sensor. So we're selecting one randomly here for this test, but you have to select your own sensor for which you want to apply the reasoning. And then you create here, you create a new rule. So you select, for example, if power less than 5 watts, then you can notify that this, for example, device is consuming high power. And then you just click and you save the rule. If you want to view the rule or edit it, you can do it here. So for example, if you were using the semantic expert rule creation component, then you should have written something like this. And this is basically the content of the rule. Now, as I mentioned before, this is basically a template of a rule. You can see here other registered templates, other created templates from other users, so that you can use it as templates in order to register your own rules. After you create a rule template, the next thing you have to do is that you have to register your rule, which means that you have to assign your rule template to a specific sensor. So what I mentioned before is that when you create a rule, you create a template so that it can be reused for multiple, to be applied on multiple sensors. And here what we do is that we want to select the sensor upon which we want to apply this reasoning rule. And we just select the sensor and we save it. If you come here to do a new execution, if you want to execute the rule, what we do is that we select the rule that we have registered through this component, the registration, not the rule template. And then it loads automatically the sensor, which we have registered, and the rule content. And here we have two different options: to select execution on the current value, the latest value, or if we want to have the reasoning upon a range of values, where we can select the start and the end date. So here, if we select the current and save it, then we will see here the latest execution. And if we click on this button to view the results, then we see that this sensor did not provide any data. But if the sensor was providing data, if we go back and see the previous execution, we can see here the result that, for example, for that execution that we did, the result was high, which meant that the rule was true. And the rule was true. This is also visible by this status here. If you want to execute again, then you just click this button and you select once again the current, but yes, you have to select also the rule, and then you save and you see the new execution, and basically that's it. Here you can also use rules created by other users, as I mentioned, in order to register your rules. And when you register it, then you go here to execute it once again and once again. You can do it multiple times without any issues. Basically, that's it. Any questions? Not really. So we can continue,
Okay.
Luis.
Okay, thank you, Elias. And then we will just finish with the tools that you have or that you will have at your hand. In this case, through the portal. And now I will hand over to Ramnath. He will be presenting you the experiment editor. I think that in this presentation that Rachid made to you, he presented the FET spec, which is this specification of your experiment, and the FET spec or the experiment editor will help you in basically creating these FET specs, the FEMO, the FISMOS, and then do it in the let's say in the most friendly manner, so that you don't have to just write yourself all the XML, but you can actually get it from the from the editor. Just we are finalizing and polishing the very last issues with the experiment editor. As you will see, they are not, or the experiment editor is not currently on the production machine, the one that you will have access to. But let's say this is in the very last polishing moments, and hopefully within the, let's say, next weeks, hopefully next days, it will be available for you. So basically we are presenting it to you as if it were already available. So Ramnath, whenever you are ready, I see that you are all ready. So whenever you want, you can start.
Thank you, Luis. Hello, everyone. My name is Ramnath. I'm from KT. Today, I'm going to present you experiment editor. Like Luis said, it was not in the production machine as of now, but it will be soon. Now I'm presenting from the development machine. Previously, Rachit spoke about the creation of FIESTA. Taking the complexity out of it, you could actually create experiments and services using this tool. It's simple GUI. You will be welcomed with this view, and once you wanted to create an experiment, you just go here and click this. This will take you to experiment. Experiment is nothing but FEMO. I don't want to go into the terminology to confuse you, but just putting out there, experiment is a FEMO and service is a FIESTA, and you have query. Now, like I said, taking the complexity out of it, you'll have experiment, service, and query. Now it's simply like experiment name. You should name an experiment following the suggestions of Rachit. So it would be something like temperature demo, maybe demo, and you should give a strong description out of it. That would be this. Okay, so you will have a list of domain of interest. Domain of interest are nothing but they kind of pose you this experiment, which domain. The name itself specifies it. What is the interest of this particular experiment? Now I'm saying it is a temperature, so it could be anything between health or city or environment or something like that. So let's say my interest is city. Then now in a sense, an experiment can have multiple number of services. So so you will be given with one service, but if you wanted to create, you can create any number of services here, and you could actually remove those services also. So now you have only one single service here. Now I'll name this service as M1. Okay, my survey, my temperature city service, city. So you provide a brief description of that service. Now every service can be visible to other experimenters. So if you keep this in the default, that means your service will only be viewed by you, but you could provide the viewability to others. So I wanted to publish, I wanted this service to be viewed by anyone, or could be this service can be taken by someone, so I'll put it in discoverable. Now experiment control. So this is where you control how a service is to be processed. In particular, it specifies the conditions where how a service should be executed. Now this provides you with date and time. So I believe you guys, like Rachit said, there is like start time should always be greater than stop time. I mean, this should be the stop time should be greater than start time, I think. So basically it should be, stop time should be in the future. Hey, so I'll select today, and date is PM at maybe 5 o'clock. 5 o'clock, okay. And stop time is around 30th at 12 a.m. Okay, close. And periodicity, we should be giving a higher value here. So I'll give 600, a 10-minute thing. And then experiment output is where you want to get this output. I'll just provide this value. CDP. Storage. Now for the files, you will have a list of files that are available, that are supported right now. So if so these are the list of files that you could select from. I'll just get a plain text, and now widget is it is the representation actually. So it defines the information of a it defines the information of an experiment in a presentation as presentation. So this is like, this is JSON format, so I'll provide just for us something around this, something like sets, I think. So it would create a widget. So you could delete any widget from here, or you can edit the data sets in the data sets that you provide. So after the service, there comes a query. In essence, actually, there is no rule that's saying that you need to have a query, but without query, you are not actually having anything from the FIESTA. So you're providing query here, so you can create a query from here. So now I can select a list of quantity kinds that are available. Okay, I guess some server problem. So let's see this. So I'll give some latitude and longitude. The quantity kind would be like temperature, humidity, and all the sensory data. Types of quantity kinds. Actually, I am sorry, I don't know why it's not loading. So I'll provide you with so you can this is actually a drop down, so you could actually select a quantity kind here and provide some location of that particular quantity kind. There might be a possibility that the sensors are not present there, but that doesn't matter. So and then you provide a query interval. you can simply provide using this. And if you provide from to date, you don't need to provide now to past time. But in case if you did provide, what happens is this will get ignored and this will take priority. So I'll provide around 6,000 milliseconds maybe. And now this is so you already selected the service. You already selected the you already gave the experiment description, definitions, and everything. So you already selected a query. Now you can build a query. Okay, so that query will be shown here. See here, this is the query that we built. You could change the filters or any parameters from here. That would be saved immediately, and then you can provide the dynamic attributes from here. So 31.01 or some values again from date to date. So we provide an attribute and then this is the saving of experiment. Current experiment is successfully saved. So if you go back, you will probably find the experiment here. Now if you want to edit this experiment in the future, you could simply go and click on the experiment anyway. So this would again let you back to the experiment. You could change anything that you previously provided, something like that. So would provide you with this, and this is the creation of an experiment, but you also have cloning of an experiment. That means you actually built an experiment and you wanted to create an exact same experiment and modify it. If a scenario is like that, then you could simply clone that experiment. That would create the clone of that experiment. Now you could modify this experiment. You can do whatever that was with. So, and for the deleting of experiment, the process is quite easy. You have a delete experiment here. You can just delete it, and let's say you have a number of experiments in the experiment editor, and you wanted to find the particular experiment. So now you can use domain of interest. Okay, let me create another experiment just to show you. Okay, so okay, so I'll create an experiment called emotion and just so if you let's say if you have many number of experiments, you probably want to select a particular get a particular experiment and edit or do something with it. In that case, you can search by domain of interest. So I can get this particular one if I want. Okay, you have emotion here. So and preview is again same like that. So it will provide you with an XML view. So that's it from me. If there is any questions, I could answer.